Students, welcome to Short's classes. This is ISI 2020 paper solution. I'm doing the part 2 of the paper. So here we are solving from question number 7. So in this question they have asked about the integral part of this. So there's a fractional part, there is an integral part. So let's just solve it. So summation, this 1 by root n. So let's put this summation. N equal to 2 to 1999, so I'm not writing the limits. N minus 1 to n, 1 by root n dx. This less than 1, 999, is reducing one value, so dx by root x. After every one value reduces. So 1 root over 9999 minus 2. This thing is 2 into 100 minus 2, that is equal to 198. So the first part is done. Then again this summation 1 by root n. This is summation n to n plus 1. Two segments I am doing. So 1 by root n dx. So this is greater than 2, 1, 2, 3, 4. Yes, dx by root x. So this is 2, 1, 2, 3, 4, 2 root 2. This is 200 minus 2 root 2. So that is greater than 197. Combining these two, the integral part of the sum is 197. So B is the answer. So 7 is done. Okay. Next go to 8. Let n be the number of subset of a given structure. So subset here. So we previously also discussed about the subset formula and all. Okay. So what they have given here is that do not contain any two consecutive numbers. Okay. So number of subset which do not contain any two consecutive numbers. So let S equal to 1, 2, n. That doesn't contain two consecutive numbers. So if n does not belongs to S, then S is like 1, 2, n minus 1. So there are n minus 1 such subsets. Okay. So if n belongs to S, then n minus 1 does not belongs to S. And if n is this, so n 1, 2, n minus 2. This is the structure. So therefore there are like n minus 2 such subsets. So answer is n equal to n minus 1 plus this, so 8n. Next is there are 128 numbers, 1, 2, 3, 4 are arranged in a circular pattern. Okay, circular pattern we know. So in the case of permutation, 1 will be less. Okay, in a clockwise order, and we start deleting numbers from this set in a clockwise fashion as follows. First delete the number 2, then skip the next available number which is 3 and delete 4. So it is like this kind of stuff. There is a very important killing the soldier type of pattern as well. Okay, we'll discuss it later. Continue in this manner. This is after deleting the numbers, keep the next available number and clockwise and deleting the number. So what is the last number left? So this is a algorithm but which 2 to the power n number of arrangement in the clockwise order. So if n equal to 1, then we will delete 2 and then the only number remaining will be 1. Okay, 1 and 2. So it's like 1 kills 2. Next, by induction we can go for the last number is always be actually 1. So assume that the statement is proof for n minus 1 and consider 1, 2, 2 to the power n arranged in a circular way. Okay, in a clockwise order. So after 2 to the power n minus 1 steps, we will delete the even numbers and we get 2 to the power n minus 1 numbers with the first available element is 1. So by the inductive assumption, the last number will also be 1. Hence, answer is 9A. The last one was a little bit of theoretical. This one is again that type. So this is about a complex number. So Z and W are two complex numbers over here. And lying on the circles of radii 2 and 3 respectively with center 0, 0. If the angle between the corresponding vectors is 60 degree, then the value of Z mod of Z plus W divided by Z minus W. So let z equal to 2 into e to the power I theta. So w equal to e to the power I theta plus I pi by 3. So z plus w, z minus w, remember that I have to do it separately, 3 I pi by 3. This is from the given structure we can write, and 2 3 e to the power minus I pi by 3. This has been done. So now this the valuation part is being left, 3 by 2 square 27 by 4, 2 minus 3 by 2 square plus 27 by 4. So 3 2 is a 4, 4 3 7, 49 by 4, so 49 and 27 76, and this is same only minus 128. Okay, so 19 by 7 root over is the answer. So is it there? Okay, so this is A. Next one.